Hi, today I thought I'd take a video on using trig functions or trig ratios to solve for missing sides and missing angles. So to start off this lesson, I want to go over here to the side and I want to write my trig ratios. So for sine, I know it's opposite over adjacent, opposite over hypotenuse. And then for cosine, I know it's adjacent over hypotenuse, so pa. And then for tangent, it's opposite over adjacent. And we're going to talk a little bit about how to use these. So in the video prior to this, we talked about how to set up these problems, but I have this angle 41. So I know I have 41 degrees and I'm going to have some relationship or ratio, either sine, cosine, or tangent, that I'm going to use to solve for x. So to angle 41, the x is going to be opposite and the 6 is going to be the hypotenuse. So I look for my relationship that has opposite and hypotenuse, and that is sine. So sine of 41 degrees is equal to the opposite, which is x, over the hypotenuse, which is 6. So then I use my calculator, and I solve for x, and so I solve for x by multiplying 6 times the tangent of 41 degrees. And so in this case, x is going to equal 5.2. The next one set up is I have 34 degrees. So in this case, I have to see what my relationship for 19 and x is. And 19 appears to be adjacent, and x is the hypotenuse. And so I can say cosine is going to be the relationship that compares adjacent and hypotenuse. So I have 19 over x. And for this one, it's a little bit different than the one before. So the first thing I do is multiply both sides by x, and then I'm going to divide both sides by cosine of 34 degrees. So to solve for x, I have cosine of 34 degrees, dividing both by. So x is going to equal 19 divided by cosine of 34 degrees. And so x in this case is 22.9. Looking at the next one, number 3, I'm going to have, again, I'm going to have adjacent over hypotenuse. And so I have cosine of 30 degrees is equal to adjacent over the hypotenuse, which is x. In this case, I just multiply by x again. Multiply by x, divide by 30, cosine of 30, and so 7 divided by cosine of 30 degrees is equal to 8.1. Moving on along, number 4 looks like it covers a different relationship. I have 28 degrees, and I have the side that's adjacent, and I have the side that's opposite. So I look up at the top of my page, and the ratio that compares opposite and adjacent is tangent. So I have tangent of 28 degrees is equal to x over 7. So to solve for x, I multiply both sides by 7. So I have 7 times the tangent of 28 degrees. And that particular problem, x is equal to 3.7. So that kind of uses the relationships there using SOHCAHTOA to solve for missing sides. So if I turn the page, though, I can use these same ratios to solve for missing angles. And in this case, I did some in class, but let's look down here at the bottom of the page. So in the bottom of the page, it says use the measure of the indicated angle to the nearest degree, or find the measure of the indicated angle to the nearest degree. And in these situations, I have all 3 of the sides, so I can use that to solve for the missing angle. So I'm just going to choose a different one each time. I'm going to choose sine, which is opposite over hypotenuse. So the sine of some angle is equal to 65 over 97. So to solve for this, I'm going to take the inverse sine, so question mark equals the inverse sine of 65 over 97. And I just use my calculator and I press second sine to show inverse sine. And then I plug in the fraction 65/97. And then I solve, and my angle is going to end up being 42 degrees because it's to the nearest. Next, degrees, I know. So I'm going to use, it's going to equal 33.5. So the inverse over 60 is my calculator, or cosine 3, solve for my angle measure to be 59. Go around, want to do number 10, I'm going to just do number 10 and use the tangent relationship. So in this case, I have, I'm going to set up tangent, which is opposite over adjacent. So the tangent of some unknown angle is 60 over 45. And so I use my calculator, second tangent, and 60 divided by 45, and I solve that angle to equal 53 degrees. And that's how you use the relationships to solve for the angles.